We will now discuss the concept of pressure, something that we hear in our everyday life. We talk about water pressure, tire pressure, air pressure. The meteorologist talks about low pressure regions, high pressure regions. We hear about pressure almost every day. What is pressure? Well, the basic meaning of pressure is force per unit area. Pressure is defined as force per unit area. Now, this is the way we define pressure. Pressure is defined as the normal force per unit area. Force applied at right angles to a unit area. So, how do we measure it? Pressure is normal force divided by the area. So what is the unit for measuring pressure? The unit for measuring pressure is Newton per meter squared, and a Newton per meter squared is called a Pascal, and we will write it using uppercase P and lowercase a. Pressure is measured in a unit called Pascal, and it is equal to Newton per meter squared. Now, if the force F is not at right angles to the surface on which it is acting, then pressure is calculated using the normal component of that force. In other words, if the force is at an angle like this, you need to take the component that is at right angles to the surface for the calculation of the pressure. If we have a force F that makes an angle theta with the surface here, then the horizontal component is F cos theta, and the vertical component that is at right angles to the surface is F sin theta. It is this F sin theta that contributes to the pressure on that surface. So in that case we will say pressure equal to F sin theta divided by A. So pressure is calculated as the force at right angles to a given area divided by that area. So if I now want to calculate the total force on a given area, all I need to do is multiply the pressure with the area. Pressure multiplied by the area will give you a measure of the total force on a given surface of area A, and the total force acting on a surface is very often referred to as the thrust on that surface. The thrust. If there is a big dam built, the total pressure of the water that is pressing onto that wall is called the thrust on the wall. So the thrust equal to pressure multiplied by the area. Let's now talk about pressure in fluids. What is a fluid? Anything that can flow is a fluid. All liquids and gases are fluids. That means all liquids and gases will exert pressure. If you go into water, for example, if you jump into water, you go and occupy the space which was being originally occupied by water. That means the water will press you from every side, asking you to get away. This is my space. You see, that means you will be subjected to a pressure. Now what happens when you go deeper and deeper into water? The pressure acting on you will increase, because there is an increasing column of air standing on you. All fluids exert pressure. Every point inside the fluid is subjected to a pressure as a result of the weight of the fluid standing above it. If you now consider a fluid inside a container, I have now got 3 points, point A, point B, and point C. Now, at all these points, there is pressure. Now, which of these points has a greater pressure? At C, we have a column of fluid which is higher than at A and B. Therefore, pressure at C is greater than pressure at A or B. I'm now going to make few statements about pressure in a fluid. The first statement is, a fluid exerts pressure in all directions. How do you know if a fluid exerts pressure in all directions? If you blow a balloon, the inside the balloon is filled with air. Air is a fluid. And why is the balloon then blown up? It is because the air inside exerts a pressure. It exerts pressure in all directions. If you make a small hole on the balloon, you can see air will rush out of that hole. The air is trying to get out of the balloon from all over the balloon. That means the air is hitting the balloon all over, and that will cause a pressure. A fluid exerts pressure in all directions. Pressure at C inside the fluid, at point C inside the fluid, it exerts pressure upward, it exerts pressure downward, it exerts pressure to the right and to the left. So a fluid exerts pressure in all directions. Statement number 2, the pressure exerted by a fluid at a point is the same in all directions. The pressure exerted up equal to the pressure exerted down, equal to the pressure exerted to the left, equal to the pressure exerted to the right. So at point C, the pressure exerted is the same upward, downward, and sideways. If you take any point inside a fluid, the pressure exerted by that point fluid is the same in all directions. Statement number 3. Pressure exerted by a fluid at any point on the same horizontal surface is the same. Now, if you consider points A and B, points A and B are on the same horizontal surface. That means pressure at A is the same as the pressure at B. Pressure exerted by a fluid on the same horizontal surface. Pressure exerted by a fluid at all points on the same horizontal surface is the same. And statement number 4, pressure exerted by a fluid at a point is directly proportional to the depth of that point from the surface of the fluid. As the point is deeper and deeper into the fluid, the pressure will increase. The pressure at a point is directly proportional to the depth of that point from the surface. It means the pressure at C is much greater than the pressure at A or the pressure at B. Now those are very important statements about pressure exerted by a fluid. Let's now talk about and obtain an expression for pressure exerted by a fluid at a particular point within it. We will obtain an equation to calculate the pressure at a point inside a liquid. Consider a small area. I have a liquid or a fluid inside a container. Now consider a small area dA in a fluid at a depth h. this area dA is at a depth h from the surface. The force acting on dA is a measure of the weight of the fluid standing on it. Is that right? If this is an area that is circular, if it is a circular area, you can imagine a tube of liquid standing on that area. That means the weight of that liquid is pressing this dA. So the force acting on that area dA is a measure of the weight of this fluid. Now, how do we calculate the weight of an object? Let's calculate the weight of the fluid standing on that area dA. First of all, what is the volume of the fluid standing on the area dA? Well, the volume is its base area. The base area is dA multiplied by the height. That will be dA times h. dA times h is a measure of the volume of the fluid standing on the area dA. Alright, if you know volume, we can find the mass. How do we find the mass if you know the volume? Volume multiplied by density will give you mass. So if you know the density of this fluid, the mass of the fluid standing on dA is its volume. Volume is dA times h. Multiply that with the density of the fluid. Now that will be dA times h times rho. Rho is the density of the fluid. I have told you, I think a couple of times before, when you want to represent the density of a substance, we use the letter rho, Greek letter rho. So this is now the mass of the fluid standing on this area. dA times h is the volume of the fluid. Multiply the volume by the density, you get the mass. Well, once you know the mass, how do you find the weight? Weight of an object of mass m is mg newtons. Is that right? Yes. So what is the weight of the fluid standing on this area dA? It is the mass. Mass is dA times h times rho. That's the mass multiplied by g. Now this is a measure of the force acting on dA. Is that a normal force? Yes, it is. If my hand is that area dA, the column of fluid standing on that area exerts a force on the area, which is the weight of the fluid, and that is at right angles to that surface. Therefore, the weight of this fluid, this quantity, is a measure of the force acting on the area dA. It's a measure of the total force, and the total force on the area we call thrust. Is that right? So dA times h times rho times g is a measure of the thrust acting on the area dA. So how do we find the pressure on the area? Pressure is the total thrust divided by the area, or pressure equal to thrust divided by the area. Thrust is a measure of the total force, and the thrust is dA times h rho g. dA times h rho g divided by the area dA, and the dA and the dA will cancel, giving us the expression pressure at a point inside the fluid is h rho g, where h is the depth of that point from the surface, rho is the density of the fluid, and of course g is the acceleration due to gravity. So if you